Welcome to Sleep Before Science Tales, the channel where we explore the universe's deepest mysteries in the most mind-bending ways possible. Where are you watching this from right now? Maybe you're cozy in your bedroom, perhaps sitting in a coffee shop, or maybe you're looking up at the stars on a clear night. Wherever you are in this moment, tonight we're diving into a question that will completely shatter everything you thought you knew about reality itself. It's a question so profound that even Albert Einstein initially rejected the answer, and when you truly understand it, you'll never look at empty space the same way again. Picture this. Right now, as you listen to these words, the space between distant galaxies is stretching by thousands of miles every single second. The universe is expanding at a rate so violent that it makes the most powerful explosion look like a gentle breeze. But here's what will break your brain entirely. It's not expanding into anything. No cosmic warehouse, no outer boundary, no bigger container waiting to be filled. And that impossibility we're about to explore together is going to take us on the most mind-bending journey through space, time, and the very nature of existence itself. Let's start with what feels obvious. Imagine blowing up a balloon in your living room. As you add air, the rubber stretches outward, pushing against the air around it. The balloon grows bigger because there's space for it to grow into. Your living room provides that space. This is how expansion works in every single thing we've ever experienced. Plants grow into air, cities expand into countryside, ice spreads across water. Always, there's a place for the expansion to go. Always, there's a boundary between what's expanding and what it's expanding into. But the universe laughs at this logic. When cosmologists tell you the universe is expanding, your brain immediately pictures that balloon. You imagine space stretching outward into something, some cosmic room, some vast emptiness waiting to be filled. You think there must be a boundary where our universe ends and something else begins. Here's where physics shatters your comfortable assumptions. The universe isn't like that balloon at all. When space expands, it doesn't push into anything. There is no cosmic living room. There is no container. There is no outside. The universe creates the very concept of space as it grows. Think of it like this, and I want you to really visualize this. Imagine trying to draw a circle that's bigger than your piece of paper. But instead of getting a bigger piece of paper, the paper itself grows to accommodate your circle. This sounds impossible because in our world, everything expands into something else. But what if you are the paper and the drawing at the same time? This isn't just a clever analogy. This is literally what's happening to reality itself. Every second of every day, space isn't expanding into pre-existing emptiness. Space is creating the very stage upon which expansion can happen. The story of how we discovered this mind-bending truth begins with a man named Edwin Hubble. Hubble was trying to settle a simple question. Are those spiral-shaped clouds of stars part of our Milky Way galaxy, or are they separate galaxies entirely? What he discovered accidentally changed everything we thought we knew about existence. Using the largest telescope in the world at Mount Wilson Observatory, Hubble spent night after night measuring distances to these mysterious spiral objects. He proved they were indeed separate galaxies, millions of light years away. But that wasn't the revolutionary part. As he plotted their distances against their velocities, he noticed an impossible pattern. Every single galaxy was moving away from us. Not just a few, not just the distant ones, every single one. And here's the part that seemed to place us at the center of creation itself. The farther away a galaxy was, the faster it was racing away from us. Galaxies twice as distant moved away twice as quickly. 3 times farther meant 3 times faster. At first, this seemed to suggest we were at the center of some cosmic explosion, like we were sitting in the middle, while everything else flew outward into empty space. But this created an impossible problem. Why should Earth be at the center of everything? The resolution was so elegant, it's beautiful. Imagine raisin bread rising in an oven. As the dough expands, the raisins get carried along with it. From any raisin's perspective, every other raisin appears to be moving away. The farther apart two raisins start, the faster they separate as the dough rises. But here's the key. The raisins aren't moving through the dough. The dough itself is expanding and carrying them along. This is exactly what's happening in our universe. Galaxies aren't flying through space. Space itself is stretching, carrying galaxies along like those raisins in rising bread. From every galaxy's perspective, they see themselves as stationary, while everything else races away. But how can we be absolutely certain this bizarre process is real? The answer lies in watching light itself get stretched and tortured by expanding space. When a distant galaxy fires a beam of light toward Earth, that light begins its journey with a specific wavelength: blue light, red light, infrared, each carrying a cosmic fingerprint. But as the light travels through expanding space, something extraordinary happens. The space the light moves through grows larger during its journey. Imagine walking across a moving walkway that's slowly stretching as you walk. Your steps stay the same size, but the ground beneath you keeps growing longer. By the time you reach the end, you've traveled much farther than your steps should have taken you. Light experiences something similar, but instead of traveling farther, its wavelength gets stretched. Blue light from a distant galaxy arrives at our telescopes as red light, not because the galaxy moved away like a speeding ambulance changing its siren pitch, but because space itself expanded during the light's billion-year journey. Here's a number that will rewire your brain. Light from the most distant observable galaxies has been stretched to nearly 40 times its original wavelength. Think about that for a moment. What started as intense ultraviolet radiation now reaches us as faint infrared heat. This means the universe expanded by a factor of 40 during that light's journey. The galaxy that sent you this ancient light looks tiny and faint in our most powerful telescopes. But when that light first left the galaxy, the universe was 40 times smaller than it is today. That galaxy was much closer to where our Milky Way would eventually form. But it's not just that space grew a little bit. It underwent massive, relentless expansion that continues right now. And here's what makes this even more mind-bending. This stretching isn't happening somewhere else. It's happening everywhere, including right here where you're sitting. Right now, the space in the room around you is trying to expand. The space between your eyes and your screen wants to grow larger. The only reason you don't notice this expansion is that electromagnetic forces between atoms are far stronger than the expansion rate. Think about that. The very space you're occupying right now is part of this cosmic stretching. You are literally sitting inside the expanding universe, not just observing it from some outside perspective. Now let's talk about the ultimate cosmic prison, and its walls are made of time itself. Every night when you look up at stars, you feel like you're seeing the universe, the whole thing, all of reality stretched out in that dark sky. But here's a truth that will reshape how you think about existence. You're seeing less than 4% of what's actually out there. You're trapped inside an invisible sphere with a radius of about 46 billion light-years. Beyond this boundary lies more universe, billions more galaxies, trillions more stars, perhaps even other versions of you experiencing this same moment of realization. But you will never see any of it. Not with any telescope humanity could ever build. Not with any technology that could ever exist. The trap isn't made of walls or barriers. It's made of the finite speed of light combined with the finite age of the universe. Light takes time to travel. When you look at the sun, you see it as it was 8 minutes ago. Look at the nearest star system, Alpha Centauri, and you're seeing 4 years into the past. Gaze at the Andromeda Galaxy and you're peering 2.5 million years into history. The farther you look into space, the deeper you peer into time. The universe is 13.8 billion years old. This means the oldest light that could possibly reach you has been traveling for 13.8 billion years. But here's where the trap becomes truly confining. Remember that space has been expanding this entire time. The most ancient light in the universe is screaming toward you right now at 600 million miles per hour, and it carries a message from the moment reality began. This light has been traveling longer than Earth has existed, longer than our solar system formed, longer than our galaxy took its current shape. This light began its journey when the universe was only 380,000 years old, back when the cosmos was a seething cauldron of plasma, so hot that atoms couldn't even form. We call this ancient radiation the cosmic microwave background, and it's everywhere. Turn on an old television between channels, and about 1% of that static comes from this primordial light. You're literally seeing the afterglow of creation flickering across your screen. So what exists beyond our cosmic prison walls? The most likely answer should both comfort and terrify you. More of exactly what you can see. If you could somehow teleport 47 billion light years away, beyond your observable boundary, you'd find yourself in a region that looks remarkably similar to here. More galaxies, more stars, more planets, possibly more life. But here's where this gets psychologically disturbing. If space is truly infinite and uniform, then every possible arrangement of matter within any given volume must repeat somewhere. This isn't mystical thinking, it's mathematical necessity. Imagine shuffling a deck of cards infinitely many times. Eventually, you must get the same arrangement twice. The universe works similarly, but with atoms instead of cards. This means there are other versions of you reading these very words right now. Not metaphorically, literally. In regions of space so distant that their light will never reach us. Quantum mechanics has arranged matter in every possible way, including ways identical to your current configuration. There are versions of you where you decided to stop watching this video, versions where you were never born, versions where the entire history of Earth played out differently. The mathematics suggests these copies exist at distances so vast that if you wrote out the number, the line of digits would stretch farther than our entire observable universe. Yet if space is infinite, these incomprehensible distances are still finite. Somewhere out there, another version of you is having this same realization about yet another version, even farther away. Let's talk about one of history's most beautiful mistakes. In 1917, Albert Einstein faced a problem with his newly completed theory of general relativity. His equations predicted that the universe should either be expanding or contracting. They allowed no static, unchanging cosmos. But everyone knew the universe was static and eternal. The idea of a dynamic, evolving universe seemed absurd. How could the entire cosmos be changing? Where would it expand to? So Einstein did something that would haunt him for decades. He modified his perfect equations. He added what he called the cosmological constant, a term that acted like a repulsive force, perfectly balancing gravity's attraction to keep the universe static. For more than a decade, this seemed reasonable. Then Edwin Hubble discovered that distant galaxies are racing away from us. The universe wasn't static after all. It was expanding, exactly as Einstein's original equations had predicted. Einstein quickly abandoned the cosmological constant, calling it his greatest blunder. If he had trusted his original equations instead of flawed observations, he could have predicted cosmic expansion decades before Hubble discovered it. But the story doesn't end there. In 1998, astronomers made a shocking discovery. Cosmic expansion isn't just continuing, it's accelerating. Something is pushing space apart with increasing strength. Einstein's blunder turned out to be essential for understanding our universe. The accelerating expansion requires exactly what his cosmological constant described: a uniform energy that fills all of space and creates repulsive gravitational effects. Einstein's supposedly unnecessary term now dominates cosmic evolution. His greatest blunder became his most prescient insight. What we now call dark energy makes up roughly 68% of everything that exists. Yet it remains completely invisible and utterly mysterious. We have no idea what it actually is. Here's what makes dark energy so weird. Unlike normal matter, which becomes less dense as space expands. Dark energy maintains constant density even as space grows. As the universe expands, new dark energy appears to fill the additional volume. This means dark energy's total influence grows over time. In the early universe, when everything was compressed together, matter dominated cosmic evolution. But about 5 billion years ago, roughly when our solar system formed, dark energy became the dominant force. We now live in the age of acceleration. The leading candidate for dark energy is vacuum energy, the quantum fluctuations that fill every point in space. But when scientists calculate how much energy empty space should contain according to quantum mechanics, they get an answer that's 1,020 times larger than what we observe. This represents the worst prediction in the history of physics. During the first fraction of a second after the Big Bang, the universe expanded more rapidly than it has in all the 13.8 billion years since. This period, called cosmic inflation, stretched space so violently that regions of the universe lost contact with each other forever. Here's a number that will break your mind. Inflation increased the size of the universe by a factor of at least 10.6. That's like a grain of sand suddenly becoming larger than the observable universe today. This expansion happened in about 10⁵ seconds, a time so short that light could barely cross the width of a proton. During inflation, quantum fluctuations were stretched from subatomic scales to cosmic scales. Those microscopic ripples eventually became the seeds for galaxies, stars, and planets. You exist because of quantum uncertainty, amplified by cosmic expansion. If inflation happened once, it should happen continuously throughout a larger space called the multiverse. Random quantum fluctuations can trigger new episodes of inflation anywhere, anytime. Each episode creates a bubble universe that expands and cools, potentially developing its own galaxies, stars, and planets. Our universe would be just one bubble in an infinite foam of realities. Most of these bubble universes would be sterile wastelands, where the laws of physics don't allow complex structures to form. But in an infinite multiverse, even the most unlikely possibilities must occur somewhere. We exist in a habitable bubble, not because we're special, but because we can only exist in habitable bubbles. So what's the ultimate fate of our expanding universe? Physics offers us 3 possible endings, each more mind-bending than the last. If dark energy remains constant, we're headed for heat death. The universe will expand forever, spreading matter and energy so thin that eventually no stars can form, no chemistry can occur, and no life can survive. In about 1,000 years, even black holes will evaporate, leaving behind a cold, empty void at nearly absolute zero temperature. If dark energy strengthens over time, we face the Big Rip. Expansion will become so violent that it eventually overcomes every force holding matter together. First galaxies will dissolve, then solar systems, then atoms themselves. Reality will literally tear itself apart from the inside out. If dark energy weakens or becomes negative, expansion could reverse into a big crunch, with the entire universe collapsing back into the hot, dense state from which it emerged. But even if we avoid these dramatic endings, expansion creates a subtler tragedy. In about 150 billion years, accelerating expansion will carry most galaxies beyond our cosmic horizon. They won't be destroyed. They'll simply recede so rapidly that their light can never reach us again. Future astronomers will observe a universe that appears to contain only our local group of galaxies, surrounded by empty space. The cosmic microwave background will redshift to undetectable wavelengths. These future scientists will see no evidence of cosmic expansion, no remnant of the Big Bang. They'll conclude they live in a small, static, eternal universe. The very evidence that allowed us to understand cosmic origins will disappear forever. But this cosmic amnesia raises a profound question about the nature of information itself. Every thought you've ever had, every memory that defines who you are, exists as specific arrangements of matter and energy in space, and cosmic expansion is slowly stretching those arrangements toward dissolution. Think about this. The information that creates your consciousness exists in the precise patterns of neural connections in your brain. These patterns depend on exact arrangements of molecules, which depend on precise positions of atoms in space. As space expands over cosmic timescales, these arrangements will eventually stretch apart. The atoms in your brain would separate by distances larger than galaxies today. The information patterns that create your thoughts would become so dispersed that no physical process could ever reconstruct them. Your identity would dissolve into the expanding void. But quantum mechanics complicates this disturbing picture. Quantum entanglement allows particles to maintain instantaneous connections across any distance. Even if expansion separates entangled particles by billions of light years, their quantum states remain correlated. The information encoded in these correlations might survive indefinitely despite spatial separation. This creates what physicists call the information preservation paradox. Information cannot be destroyed according to quantum mechanics, yet expansion seems to disperse it beyond any hope of recovery. The resolution might lie in understanding that information operates on multiple scales simultaneously. While local information patterns dissolve, global information patterns emerge at cosmic scales. The expansion history itself becomes a vast storage system. Every detail of how space has grown gets recorded in the cosmic microwave background, the distribution of galaxies, and the structure of space-time itself. The universe becomes its own memory. Let's dive deeper into what fills the space that appears empty. Empty space isn't empty. It's a seething cauldron of activity, so violent it makes the core of the sun look calm by comparison. At the smallest scales of reality, space itself bubbles with virtual particles that pop into existence and annihilate each other in timeframes, so brief you could never detect them directly. Yet these phantom particles create real effects that influence everything in the universe. Imagine zooming into empty space with a microscope, powerful enough to see distances smaller than an atomic nucleus. As you magnify further down to what physicists call the Planck scale, about 10 by 35 meters, space itself becomes grainy and turbulent. At this scale, the smooth fabric of space-time dissolves into frothy chaos of appearing and disappearing geometry. Virtual particles borrow energy from the vacuum, according to Heisenberg's uncertainty principle. The more energy they borrow, the faster they must pay it back by annihilating with their antimatter partners. These transactions happen so quickly, they seem to violate conservation of energy, but they actually obey quantum mechanics perfectly. Electron-positron pairs flash into existence for 10 by 21 seconds before destroying each other. Even shorter-lived particle pairs, involving heavier particles, appear and vanish on briefer timescales. The vacuum bristles with this invisible activity containing every possible type of virtual particle, permitted by quantum field theory. This quantum foam creates measurable effects in laboratories through phenomena like the Casimir effect, where virtual particles create physical forces between metal plates in vacuum. Now let's zoom out from quantum scales to see how expansion affects the largest structures in the universe. Galaxies aren't scattered randomly through space. They're connected by a vast cosmic web of dark matter filaments, stretching across billions of light years. This cosmic web looks remarkably like neural networks or the internet structure, with dense nodes connected by thin filaments. Galaxy clusters form at the intersections where multiple filaments meet, while vast voids contain almost nothing. As space expands, this entire web stretches. The filaments grow longer and thinner, while the voids become larger and emptier. It's like watching a three-dimensional spiderweb being slowly pulled apart in all directions simultaneously. But here's what makes this particularly fascinating. The expansion doesn't affect all parts of the cosmic web equally. Dense regions like galaxy clusters resist expansion through their strong gravitational fields. The space within our local group of galaxies isn't expanding. Gravity holds everything together. It's only in the vast spaces between galaxy clusters where expansion dominates. This creates a universe that's expanding on the largest scales while remaining static on smaller scales. You're sitting in a region where expansion has been overcome by gravity, surrounded by cosmic voids that grow larger every second. Future observations will watch this cosmic web slowly dissolve. As dark energy becomes more dominant, it will eventually overcome gravity on smaller and smaller scales. Galaxy clusters will disperse, then individual galaxies, then solar systems, potentially leading to the Big Rip scenario, where even atoms get torn apart. Let's explore how expansion affects time itself, in ways that would fundamentally alter your perception if you could experience them directly. Imagine you're an immortal observer watching the universe evolve over billions of years. As space expands, you'd notice that time appears to flow at different rates in different regions. Events in rapidly receding galaxies would appear to unfold in slow motion compared to local events. This isn't just an optical illusion, it's genuine time dilation caused by expansion. The stretching of space literally stretches time intervals. A supernova explosion that takes 3 weeks to brighten and fade in a nearby galaxy might appear to take months when observed in a galaxy at cosmological distances. But the effect goes deeper than individual events. The very concept of simultaneous breaks down across cosmic distances. Events that appear to happen at the same time from your perspective occur at different times according to observers in distant galaxies. There's no universal now that applies everywhere in the universe. The present moment is local, not cosmic. As expansion accelerates, this breakdown of simultaneity becomes more extreme. Eventually, different regions of space will be so causally disconnected that the concept of a shared timeline becomes meaningless. This has profound implications for how we think about cosmic evolution. When we say the universe is 13.8 billion years old, that's only true from our local perspective. Observers in different regions would measure different ages, and all would be equally correct. Here's a disturbing coincidence that expansion reveals. We seem to live at exactly the right cosmic epoch to discover the nature of our universe. A few billion years earlier, and the cosmic microwave background would have been too hot and bright to allow clear observations of distant galaxies. A few billion years later, and most galaxies will have receded beyond detection, while the microwave background fades to invisibility. We exist during the narrow window when the evidence for cosmic expansion and the Big Bang is visible. This seems like an incredible coincidence, unless it's not a coincidence at all. The anthropic principle suggests we observe a universe compatible with our existence because we couldn't exist in any other type. But expansion adds another layer. We observe expansion at this particular epoch because observers can only emerge when cosmic conditions are just right. Perhaps conscious beings can only evolve during the era when matter density is comparable to dark energy density, not too early when conditions are too violent, not too late when they're too empty. This would explain why we witness cosmic acceleration beginning just as complexity reaches its peak. But this raises disturbing questions about the nature of observation itself. If our cosmic perspective is fundamentally limited by when and where observers can exist, how much of what we call objective reality is actually observer-dependent? The expansion we observe might be just one layer of a much more complex reality that remains forever hidden from beings like us. Let's explore one of the most mind-bending aspects of cosmic expansion: how it interacts with black holes. Those regions where gravity becomes so strong that not even light can escape. You might think that black holes would be immune to expansion. After all, if gravity is strong enough to trap light, surely it can resist the stretching of space itself. But the relationship between black holes and expansion is far more subtle and strange. Inside a black hole's event horizon, space and time become so warped that the normal rules break down. Some theoretical models suggest that the interior of a black hole might experience expansion differently than the external universe, Time flows so differently that the expansion we observe over billions of years might occur almost instantaneously from an outside perspective of someone falling into a black hole. But here's where it gets truly bizarre. As the universe expands and dark energy becomes dominant, the expansion rate at any given location depends on the local energy density. In regions far from massive objects, expansion accelerates normally, but near black holes, the interplay between extreme gravity and cosmic expansion creates effects we're only beginning to understand. Some calculations suggest that in the far future, when dark energy completely dominates, the expansion might become so strong that it prevents new black holes from forming. The space around collapsing stars would expand faster than the matter can fall inward. Even more strangely, existing black holes might begin to dissolve, not through Hawking radiation, but through the expansion of space itself, overwhelming their gravitational grip. The event horizon might expand faster than the black hole can maintain its structure. Picture an infinite pot of boiling water where each bubble represents a separate universe. Our universe is just one bubble in this infinite foam. While we experience 13.8 billion years of expansion, other bubbles might have been expanding for trillions of years, or might have just begun expanding moments ago. Each bubble universe could have different physical laws. The strength of gravity might vary. The number of spatial dimensions could be different. Tompenla awareness dial, Tompenla awareline thing. Some universes might have no electromagnetic force, making chemistry impossible. Others might exist in permanent inflation, never cooling enough for atoms to form. The vast majority would be sterile wastelands, but in an infinite multiverse, every possible combination of physical constants must occur somewhere. We exist in a habitable bubble, not because we're special, but because we can only exist in habitable bubbles. This creates a disturbing perspective on cosmic expansion. If infinite universes are expanding in infinite ways, does our particular expansion history matter? Some argue it makes our fate irrelevant. Even if our cosmos faces heat death, infinite other versions continue in more favorable universes. But each universe might remain meaningful to its inhabitants regardless of parallel versions. The expansion we observe shapes everything about our cosmic story, from the formation of stars to the evolution of complexity, to the eventual fate of consciousness itself. This brings us to one of the most profound questions in all of science. Is there a fundamental connection between the expansion of space and the emergence of consciousness itself? Think about what consciousness actually is at the most basic level. It's the ability to integrate information across space and time, to create unified experiences from separate sensory inputs, to bind together scattered neural processes into a coherent sense of self. Consciousness requires the coordination of events happening at different locations in your brain at precisely the right moments. Now consider what cosmic expansion provides. It creates a dynamic backdrop against which information can flow, patterns can emerge, and complexity can evolve. Without expansion, the universe would either collapse immediately under gravity or remain frozen in a static state where nothing interesting could ever happen. The expansion of space might be the fundamental prerequisite for any form of information processing, complex enough to become aware of itself. The stretching of space-time creates the temporal flow that allows cause and effect relationships to unfold. It provides the arena within which neural networks can form, thoughts can propagate, and memories can be encoded. But the connection goes deeper than just providing a stage for consciousness. Some theories suggest that consciousness itself might be a fundamental feature of space-time, not something that emerges from complex arrangements of matter, but something woven into the very fabric that's expanding. Not something that emerges from complex arrangements of matter, but something woven into the very fabric that's expanding. If consciousness operates at quantum scales, then it exists at the same fundamental level as the quantum fluctuations that drive cosmic inflation and dark energy. In this view, your awareness right now is directly connected to the same quantum processes. that created space itself during the first moments after the Big Bang. The expansion that began 13.8 billion years ago didn't just create the conditions for consciousness, it created consciousness as an intrinsic property of expanding space-time. This leads us into one of the most mind-bending paradoxes in cosmology, the possibility that the universe bootstraps itself into existence through a causal loop that involves both expansion and observation. Here's the paradox. Quantum mechanics tells us that the act of measurement helps determine reality. The famous double-slit experiment shows that particles behave differently when observed versus when unobserved. Some interpretations suggest that observation doesn't just reveal pre-existing reality, it participates in creating that reality. If this applies on cosmic scales, then conscious observers play a fundamental role in cosmic evolution. The measurements we make of distant galaxies, the observations that revealed cosmic expansion, the discoveries about dark energy, all of these might be participating in the creation of the very reality we're measuring. But here's where the paradox becomes truly strange. Those conscious observers exist because of cosmic expansion, the stars that created the heavy elements in our bodies, the galaxies that provided stable environments for planet formation, the billions of years of cosmic evolution that led to complexity. All of this was made possible by the expansion we're now observing and measuring. So expansion creates observers, who then observe expansion, whose observations might participate in creating the expansion they're observing. The universe pulls itself up by its own bootstraps through a causal loop that spans billions of years and involves the emergence of consciousness itself. This bootstrap paradox might explain one of cosmology's deepest mysteries: why the physical constants seem fine-tuned for the emergence of complexity and consciousness. Perhaps they're not fine-tuned from the outside by some external designer. Perhaps they fine-tune themselves through this cosmic feedback loop between expansion, complexity, and consciousness. The universe doesn't expand towards some predetermined goal. It expands toward the emergence of observers capable of observing that expansion, whose observations then participate in determining what gets expanded toward. Now let's zoom out to consider that what we call cosmic expansion might be just one layer in a vast hierarchy of expansions occurring at different scales and in different dimensions. At the quantum scale, virtual particles are constantly expanding into existence and then contracting back into nothingness. These quantum expansions happen trillions of times per second in every cubic centimeter of space. They create the quantum foam that might drive dark energy. At the cosmic scale, we have the expansion of space-time itself, the stretching that carries galaxies apart and will ultimately determine the fate of our universe. Each level of expansion creates the conditions for the next level. Quantum expansions might drive cosmic expansion. Cosmic expansion might be necessary for the formation of observers who can measure expansion. The observations of expansion might trigger new episodes of inflation that create new universes with their own expansion histories. This creates a fractal structure where expansion occurs at every possible scale, each level both dependent on and enabling the others. You exist at the intersection of all these expanding realities, composed of quantum processes that expand and contract trillions of times per second, living in a cosmos that's been expanding for billions of years, possibly surrounded by a multiverse, undergoing its own forms of expansion in dimensions you cannot perceive. The temporal expansion paradox. Here's another layer of complexity that will reshape how you think about time itself. Expansion doesn't just affect space, it creates time as a byproduct of spatial stretching. In Einstein's relativity, space and time are unified into a single fabric called space-time. When space expands, it necessarily affects the flow of time, but the relationship is more subtle than just time dilation effects we discussed earlier. Some interpretations suggest that time itself is an emergent property of spatial expansion. Before the Big Bang, there was no time, because there was no expansion to create temporal flow. Time begins when expansion begins, and the direction of time's arrow might be fundamentally connected to the direction of cosmic expansion. This creates a paradox when thinking about the ultimate fate of the universe. If expansion eventually stops, either through a big crunch or the big rip, does time itself stop? What happens to temporal flow when spatial expansion ends? In heat-death scenarios where expansion continues forever, but all interesting processes cease, time might continue flowing but become meaningless. There would be temporal duration but no temporal direction, no way to distinguish past from future because nothing would be changing. In big rip scenarios, time itself might be torn apart along with space. The metric that defines temporal intervals could become infinite, making the concept of duration meaningless. This suggests that our normal understanding of time as something that flows uniformly might be an artifact of living during the expansion epoch. Past and future, cause and effect, the entire temporal structure of experience, all of these might be temporary features of reality that exist only while space is expanding at the right rate. Advanced civilizations trying to survive cosmic endings might need to preserve not just matter and energy, but the temporal relationships that make experience possible. They might need to create artificial spacetimes that maintain the expansion rates necessary for consciousness to persist. As we contemplate these vast scales of space and time, we face what might be called the meaning crisis of cosmic expansion. If the universe expands forever into emptiness, dissolving all structure and memory, what significance can any of our achievements have? This question has tormented philosophers and scientists since we first understood cosmic expansion. If our solar system, our planet, our civilization, our entire species will eventually be dispersed into the growing void, if even the atoms in our bodies will ultimately decay into elementary particles scattered across infinite space, then what meaning can our brief existence possibly have? Some find this prospect devastating. The philosopher Bertrand Russell wrote about the unyielding despair of contemplating cosmic endings. If everything we build will crumble, if everything we discover will be forgotten, if everything we love will perish, then perhaps existence itself is fundamentally absurd. But expansion might offer a different perspective on meaning. Rather than negating significance, the temporary nature of structure in an expanding universe might be what makes existence precious. The very fact that complexity can emerge at all from expanding emptiness represents an extraordinary achievement. Consider that in most possible universes, ones with different physical constants or different expansion rates, no complexity would ever emerge. Stars wouldn't form, chemistry wouldn't develop, life couldn't evolve, consciousness would never arise. The vast majority of possible realities would be sterile wastelands. Yet somehow, in our expanding universe, the laws of physics and the expansion rate aligned in exactly the right way to allow hydrogen clouds to collapse into stars, stars to forge heavier elements, planets to form, chemistry to complexify, life to emerge, and consciousness to develop to the point where it can contemplate its own cosmic context. This isn't a small achievement. It's perhaps the most improbable and magnificent thing that could possibly happen. The expansion that will eventually erase all traces of our existence is the same expansion that made our existence possible in the first place. As we near the end of our journey, let's confront the deepest philosophical implications of cosmic expansion. What does it mean for reality itself to grow from nothing into more nothing? Traditional philosophy assumes that something and nothing are absolute categories. Either something exists or it doesn't. But cosmic expansion reveals a more subtle reality, where the distinction between existence and non-existence becomes fluid. When space expands, it doesn't fill pre-existing emptiness with new content. It creates new emptiness that didn't exist before. The vacuum of space isn't nothing. It's a specific type of something with measurable properties and energy. This challenges our fundamental concepts of being and non-being. The The universe doesn't expand into non-existence. It expands by creating new categories of existence that weren't possible before expansion occurred. Consider what this means for consciousness and meaning. Every thought you have occurs within expanding space. Your awareness exists as part of a process where reality continuously creates new possibilities for experience. You're not just observing expansion, you're participating in the universe's fundamental creativity. Some philosophers argue that cosmic expansion makes existence temporary and therefore meaningless. If everything eventually dissolves into empty space, why does any of it matter? But this perspective might be backwards. Perhaps the temporary nature of structure in an expanding universe is what makes existence precious. The fact that complexity can emerge at all from expanding emptiness might be the most remarkable achievement in cosmic history. Let's imagine what advanced civilizations might do with their knowledge of cosmic expansion. How might beings who understand the universe's fate attempt to survive heat death or the Big Rip? One possibility involves manipulating the expansion itself. If dark energy is truly the vacuum energy of quantum fields, perhaps sufficiently advanced technology could adjust the local energy density of space. Civilizations might create safe zones where expansion slows or stops, protecting islands of complexity in an expanding ocean of emptiness. Rather than accepting cosmic fate, they might become universe creators, seeding new realities where consciousness can continue indefinitely. But all these scenarios assume consciousness can transcend its current biological limitations. The expansion that threatens to dissolve our atoms and disperse our thoughts might ultimately require us to become something entirely different, patterns of information that exist independently of matter and energy. This raises profound questions about identity and continuity. If you uploaded your consciousness to resist cosmic expansion, would the result still be you, or would it be something else entirely that merely remembers being you? As we approach our conclusion, let's examine the most radical interpretation of cosmic expansion, that it represents the universe continuously creating itself from pure possibility. Traditional creation stories assume something exists first, then makes other things. A creator precedes creation. But cosmic expansion suggests a different model, where the act of expansion is the act of creation. Space doesn't expand into pre-existing possibility. It creates new possibilities as it grows. Every cubic meter of new space that comes into existence represents new potential for matter, energy, structure, and complexity. The universe doesn't just get bigger, it becomes capable of containing more types of existence. This self-creating aspect of expansion might resolve some of cosmology's deepest puzzles. Why does the universe exist rather than nothing? Because nothing isn't actually a stable state. Quantum mechanics suggests that pure nothingness would immediately fluctuate into something. The expansion we observe might be the natural consequence of existence itself, not something that requires explanation, but the explanation for why anything exists at all. From this perspective, asking what the universe expands into becomes like asking what creativity creates. The answer isn't a destination or container, but the emergence of new possibilities that weren't available before the creative act occurred. Finally, let's consider how the act of observing expansion might be fundamentally connected to the expansion itself. Quantum mechanics tells us that observation affects reality at the smallest scales. Might this principle apply to cosmic scales as well? Every time you look up at the night sky and see distant galaxies, you're participating in a measurement that spans billions of light years. The light reaching your eyes has traveled through expanding space, carrying information about cosmic history. Your observation completes a quantum measurement that began when that light was emitted. Some interpretations of quantum mechanics suggest that observation creates rather than discovers reality. If this applies cosmically, then conscious observers might play a fundamental role in cosmic evolution. The expansion we observe might depend on the existence of observers to measure it. This doesn't mean consciousness controls expansion, but rather that expansion and observation might be aspects of the same underlying process. The universe expands by creating the conditions for observers who can measure that expansion. You are not separate from the cosmic expansion you observe. You are the universe measuring itself, creating through observation the very reality you perceive. The expansion happens not just around you, but through you, as part of the process by which existence comes to know itself. This brings us full circle to our original question, with a deeper understanding. The universe doesn't expand into anything external, because there is no external, only the continuous process of reality creating itself through expansion, observation, and the emergence of consciousness capable of asking these questions. We are not just witnessing cosmic expansion, we are cosmic expansion becoming aware of itself. Here's a possibility that might change everything. What if the universe is expanding in directions we can't perceive? String theory suggests space has 9 dimensions instead of the familiar 3. 6 additional dimensions exist right here, right now, curled up so tightly that even particles can't detect them. These hidden dimensions might be expanding along with the familiar ones. Our familiar 3-dimensional space might be expanding into higher dimensional space that contains it, like a balloon surface expanding in 3-dimensional air. We might be living on a 3-dimensional membrane floating in 9-dimensional hyperspace. Other membranes might exist parallel to ours, separated by less than a millimeter in directions we cannot point to or move in. Another version of you might be experiencing this same moment just a tiny distance away in the 4th spatial dimension. The universe might also be shaped in ways that make the expansion question meaningless. If space curves back on itself like the surface of a sphere, or wraps around like a donut, then asking what it expands into becomes like asking what a donut expands into as it gets bigger. A donut getting larger doesn't expand into anything, it simply becomes a bigger donut. The surface area increases, but there's no external space being filled. Current observations suggest our universe is either flat, or so close to flat that any curvature is undetectable. But flat doesn't necessarily mean infinite. You can roll flat paper into a cylinder, or connect its edges to make a donut shape. As space expands, it carries time along with it. This isn't just theoretical, it's measurable reality. Events in distant galaxies appear to unfold in slow motion compared to events happening nearby. A supernova explosion that takes 3 weeks to brighten and fade in a nearby galaxy takes much longer when observed in a distant, rapidly receding galaxy. So we return to our original question. If nothing lies beyond the universe, what is it expanding into? The question assumes categories that don't exist. It's like asking what's north of the North Pole, or what caused the first cause, or what contains the container of everything. The universe doesn't expand into anything because it creates the very notion of anything as it expands. The universe expands by becoming more universe, not by growing into non-universe. We are not passengers on a cosmic vehicle traveling towards some destination. We are part of the process by which reality creates itself. Our consciousness, our questions, our desperate need to understand. These are all expressions of the universe coming to know itself. The expansion we observe isn't separate from us. We are expansion. We are space and time and matter and energy, organizing themselves into patterns, complex enough to ask questions about their own existence. This realization transforms the question, what is the universe expanding into? From a puzzle about cosmic mechanics into a meditation on the nature of self-awareness itself. When you wonder about expansion, you are literally expansion wondering about itself. When you feel awe at the vastness of space, you are space experiencing its own immensity. Every neuron firing in your brain as you contemplate these ideas is made of atoms forged in the hearts of ancient stars. Atoms that exist only because space expanded and cooled enough for nuclear fusion to create elements heavier than hydrogen. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it emerged from the expansion history of our universe. But it goes deeper than just material origins. The very capacity for wonder that allows you to ask these questions emerged because expansion created conditions where complexity could evolve. The 4 billion years of evolution that produced your brain were possible only because expansion provided a stable, long-term environment where natural selection could operate. Your consciousness isn't separate from cosmic expansion. It's cosmic expansion becoming aware of itself through biological evolution. When you experience the mystery and beauty of existence, you are the universe experiencing its own mystery and beauty. When you feel small and insignificant compared to cosmic scales, remember that you contain those cosmic scales within your very atoms and awareness. Consider the extraordinary chain of events that led to this moment of understanding. 13.8 billion years ago, space began expanding from conditions so extreme that our physics breaks down trying to describe them. That expansion cooled hydrogen and helium into existence, allowed the first stars to ignite, created the heavy elements that would become planets and eventually life itself. But the universe didn't stop there. It continued expanding at precisely the rate necessary for stable galaxies to form, for planetary systems to develop, for chemistry to become complex enough to support self-replicating molecules, and ultimately for those molecules to evolve into beings capable of looking back across billions of years and understanding their own cosmic origins. You are the culmination of that entire history. Every thought in your mind represents the universe's most sophisticated attempt to understand itself. Your capacity for wonder, your ability to feel moved by beauty, your sense of connection to something larger than yourself. These aren't accidents or byproducts of cosmic evolution. They might be its very purpose. The reason expansion creates the conditions for complexity in the first place. This perspective fundamentally changes how we view our cosmic destiny. Even if the universe is heading toward heat death, even if dark energy will eventually disperse all matter across infinite space, even if consciousness itself is temporary on cosmic timescales, the fact that expansion created the conditions for awareness to emerge at all represents an extraordinary victory against entropy. For a brief cosmic moment, scattered particles organize themselves into patterns capable of love, creativity, scientific discovery, and philosophical contemplation. Stars that will burn for billions of years seem eternal to us, but consciousness emerged and flourished in an even smaller fraction of cosmic time. Yet in that microscopic window, the universe achieved something remarkable. It became capable of experiencing beauty, of asking profound questions, of feeling wonder at its own existence. Your life, your thoughts, your capacity to understand these cosmic truths, these represent the universe's greatest achievement, not because they last forever, but because they happened at all against overwhelming odds, in an expanding cosmos that could have remained forever sterile and unaware. The answer to what the universe expands into has been with you all along. It expands into every moment of consciousness, every flash of understanding, every sense of wonder at the magnificent improbability of existence itself. You are not just observing cosmic expansion, you are cosmic expansion observing itself, marveling at its own creative power to generate patterns complex enough to comprehend their own origins and contemplate their ultimate destiny. The universe expands into mystery, into wonder, into the endless capacity for more questions, more discoveries, more moments of recognition, that we are part of something vastly larger than ourselves, yet intimately connected to our smallest thoughts. We are the universe asking what it expands into. We are the expansion asking where it's going. We are space and time awakening to their own existence and marveling at the infinite creativity of the process that brought us into being. And in that recognition, the question transforms from a puzzle to be solved into a celebration of the magnificent impossibility of existence itself. Thank you for joining me on this journey through the expanding cosmos. If this video expanded your mind as much as the universe expands space itself, let me know in the comments where in this vast cosmos you're watching from. And remember, you're not just observing the universe, you are the universe observing itself. Until next time, keep wondering, keep questioning, and keep marveling at the beautiful impossibility of everything that exists.